Hello everybody, and welcome to your linear algebra review on solving systems of equations graphically. My name is Jason and I work for the ASU Tutoring Centers. Now, this question is asking us to graphically determine the solution set of each of the following system of equations and then determine if the systems are consistent or inconsistent. So let's go over exactly what that means, consistent or inconsistent. So consistent means you have at least one solution. You have at least one solution to your system, okay? Now remember, in linear algebra, having at least one solution means you either have exactly one solution or you have infinitely many solutions. Okay? You can't possibly have 2 or 3 or 87 solutions. That's not allowed. You either have one or you have infinitely many. As for inconsistent, that just means you have no solutions. Okay? So these two cases, consistent and inconsistent, cover all three possibilities you have. You can either have one solution, infinitely many, or no solution at all. Okay? So with that in mind, let's start graphically determining the solution sets of these equations. So to graphically determine them, what we're going to do is we're going to solve all of them for y. We're going to get it in the form of y equals mx plus b. Because once it's in that form, we know how to graph it, right? We know that the b is the y-intercept, and we know the m is the slope. Okay, so if we can solve for y in all of these equations, we can determine what our solution set is. So let's solve for y for this top one here, right? So let's subtract the x over to the right-hand side. So we'd have negative y equals negative x minus 3. And then I'm going to multiply everything by negative 1. So I'm just going to flip all the signs. So my first one is y equals x plus 3. Now for this next one, my first step will be to divide everything by 3. So I'm going to divide every term by 3. So I'm just going to have an x here, plus a y there. And then 6 divided by 3 is 2. So we have the negative 2 over there. And then I'm going to subtract the x over, right? So I get y equals negative x minus 2. Okay, so now let me graph these equations really quick. So this first one here, my y-intercept is 3. So it's up here at 3, 1, 2, 3. And it has a slope of positive 1. So graphically, that's going to look something like that. All right. And if we look at our second one here, it has a y-intercept at negative 2, and it has a slope of negative x. So graphically, it's going to look something like that. So we want to see where these two solutions intersect. And well, they intersect right there. So overall, we realize we have one solution. Okay, just that point at that intersection. Okay, so for this one, I'm going to go ahead and say we have one solution. Okay, cool. All right, let's move on to our next one. So again, we're going to solve for y, right? So if we subtract the 2x over, we get 3y equals negative 2x minus 3. And then if we divide by 3, we get y equals negative 2/3 x minus 1. Okay, so that's what y equals in this case. And then we're going to do the same thing here, right? I'm going to subtract the x over. And then I'm going to divide everything by 1.5. Now remember, 1.5 is the same thing as 3/2, right? So instead of dividing over the 3/2, I can instead just multiply everything by 2/3. I can multiply everything by 2/3. So I get y equals negative 2/3 x plus 4/3. Okay. So let's see what that looks like graphically. Go ahead and erase this. So graphically, I have, for the first one, a y-intercept at negative 1. And the slope is negative 2/3. So it's negative, but it's not too steep. It looks something like that. And then for the second one, it's up here at 4/3. So let's say around there. And it has the same slope. It has the same slope. It doesn't look like it, but that's the same slope, okay? So because the slopes are the same, they're never going to intercept, right? Because these lines are parallel because they have the same slope. So they are never going to intersect, which means they have no solutions. No solutions, okay? Let me go ahead and write that down. We have no solution. So the important feature here that helped us in determining there was no solution is they have the same slope, but they have different y-intercepts, okay? Which means that they start at different points and they're never going to meet because their slopes are the same. They're parallel lines, okay? So that's the important feature to determine if you have no solution. If the slopes are the same, but the y-intercepts are different, okay? All right, let's move on to our last example. Again, we're just going to solve for y here. So subtract the 5x over negative 5x plus 4, and then divide by the 15. So 5 over 15, we can reduce that to 1 over 3. Okay, so there's our first one, y equals negative 1/3 x plus 4/15. And then same thing here, we're going to add the x over. So that's positive x minus 4/5. And then we're going to divide everything by negative 3. Right, so dividing by negative 3 gives us a negative here. Let me write this a little better. Negative 1/3 x. And dividing by negative 3 here is going to make us a positive number, and it's going to be 4/15. Okay, so now the important part here is we look at them, and they're the exact same line, aren't they? They have the same slope, they have the same y-intercept. They are, in fact, the exact same line. So if we were to look at them graphically, they'd have a y-intercept of 4/15 and a slope of negative 1/3. So both of the lines look like that, which means that both of the lines intersect here, and here, and here, and here, and there, and there, and there, and there. They have infinitely many points of intersection because they're the same line, right? So that's how we know the solution set for this one has infinitely many points. This one has infinitely many points. Infinitely many solutions. Okay, so to have infinitely many solutions, they have to be the exact same line. Okay, so let's just recall. So this first one had a different slope and different y-intercept, and that's how we knew there was one solution. This one had the same slope, but a different y-intercept. That's how we knew there was no solution. And this one had the same slope and the same y-intercept, which is how we knew it was infinitely many solutions. Okay. So then overall, let's determine the consistency of these. So if you remember from earlier, consistent means you have at least one solution. So this top one is consistent, and this bottom one is consistent. And then the no solution case is the one that is inconsistent. Wonderful. Okay. Let me go ahead and clear this off right now. So if I jump over to my next slide, thank you all for coming to this quick review. For additional resources about our tutoring services that we have on campus, please head on over to that link, tutoring.asu.edu. Has every single one of the free resources we have on all of the campuses and online. If you specifically want more videos like this one that go over specific concepts, or you want to maybe look at our upcoming reviews that we have for some classes exams, you can go ahead and click on that link specifically. Okay. Thank you all very much and have a wonderful day.